Hello, let me go over the solution for assignment 4. The first problem here, I ask you, we have 4 group, freshman, sophomore, junior, and senior in high school, in College of Nursing, and I ask you if we doing the physical activity, what statistical test we're going to use to examine if the mean of physical activity is different from these 4 groups. If it was 2 group, then you could have 2 sample t-tests. You could have there was no proportion, so that option is not correct. So analysis of variance is ANOVA is the correct one. Then how are you going to set up your hypothesis? Because you have 4 groups, so the null would be mu1 equal mu2 equal mu3 equal mu4, and the alternative would be at least one test is not equal. So that's the correct answer. Question 2, we have 3 treatment and with reducing stress, and these are the information 5 subject for each group, and we have the total, means, variance. I ask you to calculate sum square between, within, total, F value, and do the hypothesis testing. If you look at the sum square between, if you remember, for between, you multiple the sample size by taking the square of the difference between the mean for that group minus the overall or grand mean. So that was for mean for group 1, 17.6 was for your group 1. The overall mean was 23.07. You square and you do for the second and third group, you get 368.5. For within, you using the variance multiple by each group minus 1, the degree freedom for each group, n1 minus 1, 5 minus 1 times the variance for group 1, variance group 2, and variance group 3, you get 244.4. And sum square total is adding these two. So those are your sum square between, within, and total. Then you can create the ANOVA table. So your degree freedom is k minus 1. You have 3 group minus 1, 2, n minus k is 15 minus 3, 12. And these are sum squared. Then you get the mean square, which is mean square is sum square divided by degree freedom. 368.5 divided by 2 give you 184.25. And the same, you get mean square error, 244.4 divided by 12, you get 20.37. And the F is 184.25 divided by 20.37, you get 9.05. This is your hypothesis, and the critical value is you're using 2 and 12 degree freedom because between is 2 and 12 with 0.95. From F table, 2 and 12 for alpha 0.05, you get 3.885. If you round it to 3.89. Since your test statistics is greater than 3.89, the critical value from table, you would reject the null, and you would conclude there is at least one difference regarding reducing stress. Question 3, I give you the Tukey and Bonferroni method, and based on Tukey method, you have asterisk group 3 and group 1 different. This is the same as 1 and 3, so there is actually one comparison here for these. You can, because comparing group 3 and group 1 is the same as group 1 and 3. So, and here, Bonferroni method, it shows by connecting letter. That means 3 and 2 are the same, 2 and 1 are the same. The only group is not connected is 3, 1. So both group Both methods show group 3 is only different from group 1 correct answer. Question 4, we have two factors now, working status and physical activity, non-light, moderate, and working stat 2 level, and we are looking reducing anxiety. So from SAS output, I ask you to find the F value. The F value is 25.3A, and I ask you what effects are significant. You're going to exam type 3 sum square. That for factor A, your factor A is your physical activity, factor B is your working status. So both of those factors are significant. The interaction effect is not. The p-value is 0.54, which is less, much greater than 0.05, your alpha, so it's not significant. Then I ask you to do comparison here. See, group 1 here is light, group 2 is moderate to light, high, and group 3 is none. So basically, when you have multiple comparison this way, then you would comparing either top or bottom of this diagonal. 1 versus 2, which means light versus moderate, is significant because the p-value is less than alpha 0.05. The same light versus none, and also moderate versus none is significant. So all three groups are significant. So group high is different from moderate and none, and also group moderate is different from none here. So that's the correct answer for this question. So again, group light here is different from moderate and none, and also group moderate is different from none. So that's the conclusion you wanted to make for this assignment. And next problem is another problem with factorial design, which we are looking the effect of 3 different treatments on depression use on 30 randomly selected patients in one clinic. So we have gender not 3 treatment. Again, if you look at the SAS output, the F value is 64.70. What factor are your factor A treatment, factor B is gender. So if you look at type 3, all effects are significant. The interaction, gender, A and B factor, which is your treatment. So factor A, B, and interaction effects significant. How many significant difference you find for adjusted 2-key? Again, you're going to look at, remember, it's the output, put the name it 1, 2, 3, 4, 5, 6, 4, the combination of group you have. So treatment A1 female is 1, treatment 1 female is 2. So basically, again, you're looking at the either upper diagonal or lower to find. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. P-value is less than 0.05. That is the correct answer, the number of significant 10. Next question, we have relate to chi-square test. I asked to calculate the expected value for cell 1 and 4 and chi-square, and if that is independent or homogeneity. Remember, we have 1 sample, 2 factor, that would be independent. If you have 2 population or 2 sample, then it would be homogeneity test. So basically, the expected value for each cell is the marginal for row and column for that cell divided by the total. So for cell 1 is 340, for cell 2 is 60, for cell 3 510, for cell 90. And then you're using the chi-square, observed minus expected square divided by expected for each cell. When you add up, you get 52.9. So your hypothesis is breastfeeding and breast cancer are independent, alternative are not. Since the 52.29 is much greater than your value from table 6.635 with 1 degree freedom and 0.99, you reject and you conclude the association between breastfeeding and breast cancer. The next question, you have two population, male and female, and you wanted to see a smoking, anyone a smoke or not. Again, the expected value for cell 2, 3, the same way you calculate is 72.5 and 27.5. Your hypothesis now is homogeneous for male and female smoking status because we are looking at two populations. And when you calculate observed minus expected for each cell square divided by expected, you get 0.63. And this value is not greater than 3.841, your critical value. We failed to reject. So the correct answer is 72.25 and 0.63 and homogeneous test, and no, because your chi-square test is less than the chi-square value from table. And question 8 is we have time 1 and time 2 for 100 students in terms of some intervention if they reduce the smoking. So you're using the McNamara test here. So I ask you to calculate the test. So basically is your N1 2 minus N2. So that's your N1 50, the 1 no yes versus yes no minus 30. Square divided by that, you get 5, and you compare it to chi-square value 3.841. Since this value is greater, then you reject your null and conclude there is evidence which the intervention work and reduce your quitting smoking. And for factor related to smoking in college women, table 1 use chi-square test and what variable were significant for that. This is table 1 for factor related to. So if you look at table 1 here, tell you which variable were significant. A is 0.001 and then the E, which is 0.06. So AE is your race and working status is less than 0.05, both race and let me go back to that. Alcohol, sorry, race and alcohol is the one is significant. 0.06 is borderline, so for the E part, working status. But alcohol, if we consider 0.05, so alcohol and race is significant. What is the p-value for working status? 0.06. These tests are an independent because you're looking at the relation between two variables. And for the alcohol, what statistical tests were used was analysis of variance used, and how many groups were examined for this test? There was 4 groups, and p-value for which one were significant by group, education and income were significant. So for if you look at table 1, again, here it tells you PO3, education and